Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into what exactly is CSI specification, what is CSI container storage interface, what is CSI specification, and how can storage providers use CSI specification to write CSI plugin that can be used to dynamically provision volumes on top of Kubernetes. So before actually moving into a lot of these details, let's very quickly try to talk about volume provisioning on top of Kubernetes. We have already talked about this in some of previous videos, but just to set the context, let's talk about volume provisioning on top of Kubernetes. So let's say you have an application that uses persistent volume, that uses volume to store the data, and you want to deploy that application on Kubernetes. In that case, there are chances that you would want the volume to be available on the node. So let's say this is the node where you are deploying your application. This is your application, and if this application uses a volume, in that case there are chances, or in most of the cases, you would want that volume to be available on this particular node. So now to get this volume available in this particular node, we can either ask someone before deploying our application, we can ask someone, let's say, who has the authority, privileges, or let's say resources to provision this volume before we deploy the application. So we can ask them to provision this volume, and then we can deploy our application and we can attach our application with the provisioned volume. So that is one way where we let's say statically ask administrators to provision the volume, and then we deploy our application using that volume. So that is one way, and we call that particular way static provisioning. I think that is self-explanatory, because before deploying application, we need the volume to be present on the node. But this particular approach a lot of times is not that scalable, let's say, because if you have to deploy, let's say, a lot of application, in that case, this entire workflow of provisioning the volume can be quite time consuming and is not scalable. So for example, if you have to deploy an application, you have to ask someone to provision that volume manually, and then your application would be deployed. And like I said, if you have n number of applications, it is going to take a lot of time. That is the reason this particular application is not very scalable, and that is the reason we try to provision the volume dynamically on the cluster. So when we say provisioning volumes dynamically, what we mean is when we try to deploy an application, what we can do is we can specify that this is how much storage I need or my application needs, and then that particular volume, that much volume is going to get provisioned dynamically, and it would be ready for us to use. That is what dynamic provisioning is. I have talked about these things in one of the previous videos. Maybe I'll link that down in the description. So now that we know what static and dynamic provisioning is, now let's focus on dynamic provisioning. So to enable dynamic provisioning, what we can do is, let's say, if there is a way to specify that, okay, I want to provision volume from this particular storage provider, let's say. So for example, let's say our cluster is on Google, and I want to specify that I want to have volumes using these many properties. So what we can do is we can call, let's say, or Kubernetes can call the cloud providers. Let's say CP is cloud providers, so cloud providers API. And let's say this is a node. Let's say this is a Kubernetes node. This is a Kubernetes node, but let's say this is where we have Kubernetes code as well, roughly. So let's say we are going to, or this Kubernetes is going to call cloud providers APIs to actually provision the volumes dynamically. And this particular code that is calling cloud providers APIs to provision the volume initially was being shipped with Kubernetes itself, and that is the reason I was saying, let's say this particular code is part of Kubernetes only. Now, this mechanism of enabling Kubernetes to talk to cloud providers to let's say provision volumes was called, let's say, in-tree provisioning, right? Because the code that was responsible to provision the volume was being shipped with Kubernetes code base itself. That is the reason we used to call it in-tree provisioning or in-tree mechanism, let's say. But again, there are a lot of problems with this particular approach, and one of the problems or some of the problems that we can talk about is if this particular code is being shipped with Kubernetes, in that case, let's say if storage provider wants to update something, they will have to wait for Kubernetes release to get their code shipped. So they have a dependency on release cycle of Kubernetes, and if Kubernetes is not released, in that case they will not be able to get their newer version released. The other problem that I see is if Kubernetes is shipping storage providers code, or let's say cloud providers code, in that case, there are chances that our Kubernetes maintainers will have to make sure that the code that is being delivered as part of Kubernetes is actually secure, let's say, doesn't have any vulnerabilities. So that is adding another let's say headache on Kubernetes maintainers. The other problem with entry provisioning or entry mechanism that I can think of is, let's say someone is on a Kubernetes cluster that is on Google, and if code to provision the volumes on other cloud provider is also being shipped with Kubernetes binary itself, Kubernetes code itself. In that case, if you are on Google, you don't actually need the code to provision volumes on, let's say, DigitalOcean or let's say AWS. So all those storage providers code is actually extra, let's say, is not needed because you are on Google. So because of all these reasons, again, this particular mechanism where we used to ship storage providers code along with Kubernetes was not actually a good idea, and that is how, or that is where the CSI uh, comes into picture. So what happens is, in case of dynamic provisioning, again, if we look into this particular diagram, if we say that, if we specify that we want to provision the volume dynamically, what happens is the controller that is running on the Kubernetes cluster, again, I have talked about it in previous videos, that controller uh, sees the request. Most of the times it is going to be persistent volume claim API. So the controller looks at that request and it figures out if Kubernetes can provision that volume or not. So it checks if the volume that matches the request is already present on the cluster. It also makes sure that if Kubernetes in-tree provisioners can be used to actually provision the volume, and it checks that by seeing or by looking at the provisioner that is used in the storage class, that is used in the PVC. So when we create a volume request, we do that by creating a PVC resource, and in PVC resource we specify storage class as well, and storage class provisioner is used to figure out if in-tree provisioner is supposed to be used. And if it figures out that in-tree provisioner cannot be used, in that case, Kubernetes does not actually provision the volume by itself. Kubernetes just adds a specific annotation on the request, on the volume request, and it's basically done, because Kubernetes in itself doesn't know how it can provision the volume. And again, I have talked about this entire thing in a lot more detail in one of the previous videos. So that is the reason I'm not going into much more detail. But if you want to have a look, I'm going to link that down in the description. So again, persistent volume controller sees that, okay, entry provisioning is not being used, volume is not already provisioned by administrator. In that case, it just annotates the volume request with a particular annotation called volume.kubernetes.io slash storage provisioner. I think that is the annotation, and Kubernetes doesn't do anything after that. And after that, uh, that is where the CSI plugins or CSI specification comes into picture to provision the volume. So now, if we talk about CSI specification, so CSI specification is, let's say, just a set of rules uh, that are supposed to be implemented by the storage providers if they want that their volume can be provisioned on a Kubernetes cluster. So let's say this is the uh, Kubernetes cluster that we have, and we have some storage providers. For example, let's say AWS, and we have another example, let's say GCP, we have a DigitalOcean as well, and this is the Kubernetes cluster. So CSI specification, this can be Kubernetes cluster, or this can be any other container orchestrator. For example, it can be Mesos, it can be Nomad, I think. Yeah, I mean, CSI specification is not actually just for Kubernetes. CSI specification is for all the container orchestrators out there, and it just specifies how these storage providers, if they want to provision volumes, or if they want to provision the volumes on the container orchestrator, so that the workloads that are running on the container orchestrators can use those volume, what are the rules that they have to adhere to, or how they can write the component, the program that can be used by the container orchestrator to provision the volumes in the respective storage provider. So these are called, let's say, storage provider. This is container orchestrator, and in CSI specification, it's just defined how, or what are the rules that a particular storage provider has to adhere to, so that container orchestrator can actually provision the volumes in the respective storage provider. And the program or the application that these storage providers write that implements this CSI specification is called CSI plugin. So let's say if CSI specification is defining a set of rules, that these are the rules that a particular storage provider has to implement or has to support if that storage provider wants that their volume can be used on container orchestrator dynamically. In that case, these are the rules that they have to adhere to. If they write a component by implementing all those rules, in that case, that component or that application is called CSI plugin. So this is the basic definition of, let's say, CSI specification and CSI plugin. Now, these rules that CSI specification, again, we are going to look into this in a lot more detail. So these rules that CSI specification specifies are actually divided into some groups, let's say. So for example, some rules must be implemented by CSI plugins, some rules should be implemented by CSI plugins. So these rules are actually separated or grouped together in some conditions. For example, must, should not, must not, and things like that, right? So all those rules are grouped together in these categories. Now, let's talk about why exactly CSI specification is necessary. So again, because let's say container orchestrator wouldn't know how the volume is provisioned in all these storage providers. There are chances that there are other storage providers as well. So orchestrator does not actually know how it can provision volume on, let's say, a specific storage provider. That is the reason CSI specification says that, okay, if, let's say, this particular storage provider, or if container orchestrator wants to, create a volume on a specific storage provider, in that case container orchestrator is going to call a method called, let's say method 1, right? And in that case, if storage provider wants that container orchestrators should be able to provision the volume using their implementation, in that case they are going to write a program, a component that is called CSI plugin, and that CSI plugin is going to implement M1 method, right? And as soon as this M1 method is implemented by the CSI plugin, container orchestrator knows that M1 is the method that can be used to create the volume. So it is going to, as soon as it knows that the volume request that was made in the container orchestrator is for this particular CSI plugin, this container orchestrator is going to call M1 method. And this M1 method is because, again, M1 method is in CSI plugin. It's not actually in CSI specification, it's in CSI plugin, and CSI plugins are implemented for each storage providers. In this CSI plugin, they would obviously have implemented how volume can be created on AWS, again, if this CSI plugin is for AWS, right? Similarly, let's say if I have my own storage company, let's say it's called block storage block storage on scale, right? And I want that people should be able to use my volumes on Kubernetes cluster. What I would have to do is I would have to write another CSI plugin for this particular storage, and I will have to implement this particular method like it's specified, like it's expected in the CSI specification. And once I have implemented this particular method, container orchestrator is going to see if that volume request was made for this particular CSI plugin, and this is going to get called. And again, because it's in CSI plugin for BSOS, respective API for BSOS is going to get called. Similarly, if we talk about DigitalOcean, there would be a CSI plugin for DigitalOcean that would implement this particular method. And this particular method, let's say, again, let's call it create volume, let's say create volume. So this particular CSI plugin for DigitalOcean is going to implement create volume. And again, create volume, because this is specifically for DigitalOcean, create volume would know, or create volume can call any API for DigitalOcean to create the volume. And now container orchestrator, because of CSI specification, knows that create volume is the method that should be called to create the volume. Now, the other thing that I want to talk about is what are the other things that CSI specification talks about. So now, again, container orchestrator is supposed to call the CSI plugin, but CSI specification also says how the CSI plugin, or how these methods that are specified in CSI plugin must be implemented, and whether those APIs should be exposed via, let's say, a REST endpoint, or should it be gRPC, and things like that. So that is another thing that is specified by CSI specification. Because if that is not specified by CSI specification, how would container orchestrator know that how it is supposed to call that particular endpoint, if it doesn't know if it's REST endpoint or gRPC service, let's say, right? So these are all the things that CSI specification actually specifies. Now, we have already talked about that all the rules that are specified CSI in CSI specification are categorized in, let's say, some groups. For example, these rules must be supported, these rules should be supported. So all the rules that are specified as must, required, and shall, if all those rules are implemented by CSI plugin, in that case, that plugin is going to get called CSI specification compliant, let's say. But if they are not supporting, if they are not implementing all the let's say services or all the rules that come under must, shall, and required, in that case that CSI plugin will not be actually called compliant with the CSI specification. uh, so again, if I try to summarize this, CSI specification actually is a rule book that helps container orchestrator to interact with CSI plugin. So yeah, this is, let's say, this is the most important part. If you have to define it very briefly, you can say that CSI specification is a way using which container orchestrator, using which or using you, this is the rule book using which container orchestrator knows how it can call the CSI plugin. Right now, one of the examples that we saw is, let's say, container orchestrator is supposed to create a volume. In that case, CSI specification says that to create a volume, this particular method should be called. That method can be anything, but for now we are talking about create volume. Let's say name of that method is create volume. So in that case, if you see, container orchestrator now knows that create volume of this particular CSI plugin should be called to provision the volume dynamically. Similarly, let's say if container orchestrator has to delete the volume, in that case, CSI specification also says that which particular method should be called to delete the volume. Right? Does that make sense? So yeah, I think uh, this is it that I wanted to talk about CSI specification. If you have any questions about this, don't hesitate to post them, or ask them in comments or anywhere you want to. Now, if we talk about all these methods, right, or we can call them services as well. All these methods are grouped together in three services, and those three services are identity service, controller service, and node service. So all these services that are part of CSI specification are grouped together in three services and are supposed to be implemented by CSI plugin. So if we talk about those services, so this is the CSI specification that CSI that can be found in CSI org, and then spec is the repo. And if you go ahead and try to look into all these services, if you see here, we should have identity service, controller service, and node service. And in case of identity service, the services or the RPCs that are defined in identity service should be implemented by controller plugin and node plugin as well. Now, before actually moving further, let's talk about what are controller plugin and node plugin. So if you see here, we saw that CSI specification must be implemented by CSI plugin, and again, CSI plugin is nothing but let's say a very well written program or application. So this CSI plugin basically has two components, and those two components are node plugin and controller plugin. Now we are also going to look into how people implement that, how we can implement that. But for now, you can just assume that there are two components to a CSI plugin called node plugin and controller plugin. Now, node plugin controller plugin is basically responsible to interact with the storage provider. So for example, if container orchestrator is going to make request to CSI plugin, uh, in the cases where CSI plugin has to interact with storage provider. In that case, controller plugin is going to get used. But in the cases where let's say uh, there is a request to do something with volume and node. In that case, so again, if I try to explain that a bit, uh, for example once we have the volume available on the node, let's say we have to mount that volume on the pod. In that case, if you see here, volume and node are related. That is the reason this service, this RPC, or this implementation would be implemented by node plugin, right? So that is the reason we have two components that are there in the CSI plugin. One is controller plugin or controller service. Another one is node service or node plugin. Now, so if we go ahead and try to look into identity service once again, if you see, it says that both node plugin and controller plugin must implement this set of RPCs. So all the services, all the RPCs that are defined in identity service, all those services must be implemented by controller plugin as well as node plugin. Now, if you see, there are some services that are grouped together in controller service, and all those services must be implemented by controller plugin, as you can see here. And similarly, the services or the RPCs that are specified in node service must be implemented just by the node plugin. And these are all the plugins. If you see here, these are all the services, let's say, or all the RPCs that are defined for a particular service. So for identity service, we have get plugin info, get plugin capabilities, and probe. So I think, yeah, using get plugin info, we are going to return some details about plugin. For example, let's say plugin name, etc. Because this is how container orchestrator is going to know if this is the plugin using which the volume should be created. Because let's say if there are n number of CSI plugins installed in your cluster, how would container orchestrator get to know that this is the plugin or yours is the plugin that is supposed to be called to provision that volume? So this is how get plugin info returns the plugin name, and that is matched again against the provisioner. In case of Kubernetes, that is matched against the provisioner that is specified in the storage class. And if that provisioner matches with the get plugin info, in that case, this is the plugin that is supposed to be used. Again, all these things are going to make much more sense when we actually implement this. So yeah, in the future videos, obviously it's going to make much more sense. Uh, get plugin capabilities actually specifies what are all the capabilities that this particular plugin has. For example, does this has controller service as well, or it just has node plugin, it doesn't have controller plugin, and things like that. We are also going to look into how these request and response look like, so don't worry about that. And probe is, again, like the name suggests, it is going to get called just to make sure that your plugin is ready or not. Now, if we talk about controller, all these RPCs are part of controller service. And one RPC that I want to talk about is, if you see here, get controller get capabilities. And this is, so all these RPCs that are defined or that are grouped together in different services. So all these RPCs are not actually mandatory or required. Some of these RPCs are required, but some of these RPCs are optional. So Container Orchestrator can figure out if optional RPCs are implemented or not by calling controller get capabilities. Or similarly, in case of node service as well, we should have node get capabilities. So for the optional RPCs of node, container orchestrator can call node get capabilities to figure out if optional RPCs for node plugin are implemented or not. So if you see here, this is the, let's say, this is the crux, or this is the backbone of CSI specification. So all these services are grouped together in three services, and these three services are going to be implemented collectively by two components called controller plugin and node plugin. Identity service is going to be implemented by both the components controller plugin and node plugin. Controller plugin or controller service is going to be implemented by controller plugin. Node service is going to be implemented by node plugin. And like I said, some of the RPCs are not mandatory, not required. So container orchestrator can figure out if an optional RPC is implemented or not by calling node get capabilities. So yeah, apart from that, the other thing that I wanted to talk about is, let's see, we have two components. How do we actually build these two components, and how do we deploy these components? So what you can do is, you can actually, in most of the cases, you can have a single application or a single binary, let's say, that implements both, let's say, node plugin as well as controller plugin. And this particular binary or application can be deployed as let's say node plugin or controller plugin. So you can specify let's say an environment variable, right? And by reading that environment variable, your application can either run on node version, or let's say or let's say controller version. So it depends on, this is not actually defined by CSI specification. So this particular thing is not part of CSI specification. It totally depends on storage provider, how they want to differentiate between node plugin and controller plugin. But node plugin and controller plugin can be part of single binary. And when they are single binary, if we talk about how they can get deployed on a Kubernetes cluster, so there are a lot of ways using which they can get deployed on Kubernetes cluster. And to do that, to see that, this is the diagram that we are going to look into. So if you see here, controller plugin is actually deployed on the leader node, and the node plugin is deployed on the all follower, all worker nodes. And node plugin is actually supposed to run on all the follower nodes, all the worker nodes. So again, it depends on, or it's responsibility of the supervisor, how they want to run node plugin, so that node plugin is being run on all the worker nodes or all the follower nodes. This is one architecture. The other architecture to run your CSI plugin is, if you see here, controller plugin and node plugin are separate binaries, but they are being run just on the worker nodes or just on the follower nodes. And if you see here, the other architecture, in the other architecture, we have controller plugin as well as node plugin. So again, both of these plugins components are part of single binary, and they are just running on the worker nodes. So this is another implementation. And here, if we don't have a controller plugin, we are just running node plugin on the worker nodes of your container orchestrator, let's say. So this is how CSI specification specifies that you can deploy your CSI plugin, right? Uh, Now, if we talk about, let's say, if we go back to this particular diagram, where, let's say, CO has to container orchestrator has to create a volume dynamically. How can that be done? That is also, and basically that is what CSI specification specifies, right? It specifies how a volume can be provisioned dynamically for different storage providers, right? So let's go ahead and try to look into that as well. So let's say we have let's say we have a container orchestrator. Let's say in our example we have Kubernetes, and we have a storage provider. Let's say DigitalOcean. So what CSI specification says is, to actually provision a volume, what exactly is going to happen is, container orchestrator, and again this storage provider is going to implement a CSI plugin. So have it let's have it installed in the cluster. So let's say this is the CSI plugin that is provided by DigitalOcean, and is installed inside the container orchestrator using any of the architectures that we just talked about, or that we just looked at, right? So to create a volume, what container orchestrator is going to do is, it is going to make a request to the CSI plugin, and this request is going to be create volume. So create volume again is an RPC that is part of controller service. So if we go ahead and try to look into the RPCs for controller service, if you see here, control create volume is an RPC for controller service. So create volume is going to get called by container orchestrator, and once create volume is called, this CSI plugin again, this I mean, you cannot, at least now you cannot say that what if create volume is not implemented by CSI plugin, because if it's a CSI plugin, it simply means that it implements the CSI specification, or it adheres to CSI specification. And if it adheres to CSI specification, in CSI specification, if you again, in the first document that we have been looking into, it's clearly mentioned that these are all the RPCs that must be implemented by CSI plugin, right? So yeah, I mean, that's not a chance that create volume is not implemented. So create volume was called. Now CSI plugin, since it is for DigitalOcean, it exactly knows how a volume can be created, and this CSI plugin just called respective APIs to provision the volume. And once the volume is provisioned, let's say this is the volume that got provisioned after the call was made to storage provider. And once the volume was provisioned, this volume is supposed to be added to the node, right? Because or this volume is supposed to be attached to the node. So let's say again a call is going to be made, and I'm going to call it second call, and this second call is going to get called is called, let's say, controller publish volume. Controller publish volume, and controller publish volume is actually going to attach the provisioned volume with your node. And once the volume has been attached to the node, again there are chances that this volume is going to be attached to your node, and it would be available in your node as a device file that we are going to look into when we implement this. But yeah, for now, let's say that the volume has been attached to your node. And once the volume has been attached, what we are going to do is, we are actually going to make this volume available inside a workload, let's say. So in case of Kubernetes, let's say inside a pod. So let's say we are running a pod here, so this volume that is available on the node now should also be available in the pod. So now in some cases, this process, making this volume available inside the pod, is two-step process. So initially we are going to make this volume available in a staging path, right? And once it is available in the staging path, then in the next step we are going to actually make that available inside the pod, right? So this is the third step, this is the fourth step, and third step is going to get called node stage volume, and fourth step is going to get called node publish volume. And so this is the workflow to get a volume provisioned using a CSI plugin that follows the CSI specification. Or in other words, CSI specification says that if a storage provider or if a CSI plugin wants that the volume using this plugin can be dynamically provisioned on Kubernetes. These are all the RPCs that must be implemented by the CSI plugin. And if you see here, if this did not make much sense, we are going to talk about it in a lot more detail when we actually implement it. But for now, this is the workflow. Let's say again, if we go to the specification here, so if you see here, this is an example. So create volume was called. In that, after that, controller publish volume is going to get called, and controller publish volume is actually going to attach the volume with the node as a device file, and then node stays volume is actually going to make that volume or make that device available as a directory, as a file, let's say on a staging path. And after that, node publish volume is actually going to make sure that that volume is available from staging path or mounted from staging path to your actual pod. So this is the workflow. This is one of the life cycle of the create volume request. So now that we know CSI specification is actually specifying all the, let's say, RPCs, all the methods that should be implemented. It also specifies how the request and response to those endpoints, how their format looks like. So for example, if we talk about create volume, if you see create volume request and it returns create volume response, so it also specifies how the request and response should look like. And it also specifies if it returns any error, how that error, what are all the errors that this particular call can return. Because if this specification specifies what are all the errors that can be returned, in that case container orchestrator would actually know how to handle those errors. If it doesn't know, if container orchestrator doesn't know what are all the errors that are going to get returned, in that case container orchestrator wouldn't know how to handle those errors. So that is the reason it also specifies request, response, and errors as well. So for example, if we look into create volume, let's say, and if you see here, create volume, it has all the details why create volume is used. And if you see here, it also specifies create volume request, and it should also specify how the error looks like and what are all the errors that create volume can return. So for example, if source does not exist, not found. And again, if you are coding this in Golang, you can use gRPC standard codes. These are, if you see here, these are gRPC standard codes to return it back to the container orchestrator. And if you, for example, have to pass, let's say, create volume request, you can also very easily see that if we go to again, I'm in CSI spec itself repo, and if we go to csi.protobuf.go, and if we look into, for example, create volume request struct, this is the struct that we are going to, or that our plugin is going to get when create volume is called by container orchestrator. So if you see here, name, capacity, range, and things like that. So yeah, these fields are pretty good commented, I would say. So yeah, if you just read the comment, you would be able to understand what are the significance of these fields. So yeah, the thing that I was trying to mention is it also specifies how the request to that RPC, request and response to that RPC is going to look like, as well as the error codes. Now, if we talk about, let's say, error codes, these are the error codes, standard gRPC error codes that we have been talking about. So for example, if you have to return, let's say resource exhausted, uh, this is what you can return, code 8, from your implementation. This is the code. The other thing that I wanted to talk about is in some of the RPCs, uh, it doesn't matter which particular plugin, node or controller, which plugin that RPC is going to be part of. But for some RPCs, CSI specification explicitly says that whether that RPC should be idempotent or not. And again, we are going to talk about this definition of this word in just a second. But for example, if we talk about, let's say, create volume, and specification explicitly says that this operation must be idempotent. It simply means that if idempotency simply means that a particular if a particular endpoint, if a particular request is being hit with the same request, with the same payload, more than once, there should not be any side effects, or it should not fail. That call should not fail unexpectedly, but it should return a valid response code without being failed. So for example, if it's called for the same volume, instead of this call being failed, it should return that the volume is already created. So that is what it means for a service to be idempotent. And for some of the RPCs, CSI specification clearly says that that particular RPC should be idempotent or not. The other thing that I wanted to talk about is, for some of the RPCs, if we go ahead and look into these RPCs, some of the RPCs are actually required. And in that case, I think I have already talked about it. But for example, let's say controller get capabilities, or let's say node get capabilities. So in case of all these RPCs, some of the RPCs are required, some of the RPCs are optional. For example, node stays volume is optional RPC, right? So again, if we go back to this particular diagram, the third step here, that is node stays volume, this is an optional RPC, right? So if your plugin implements an optional RPC, you can specify that using node get capabilities. Because if you do not specify if an optional RPC is implemented or not, how would Container Orchestrator know if it has to call node stays volume or not, or if it has to call the optional RPC or not? That is the reason you have to, or you should specify all the optional RPCs that you implement using node get capabilities. Now, all the required RPCs are going to get called anyway. So that is the reason you don't have to specify those RPCs or required RPCs in node get capabilities. Again, if I try to summarize that, all the RPCs that are part of, let's say, either controller or node plugin can either be required or optional. So required RPCs are going to get called anyway all the time. So all the times, so you don't have to specify explicitly about required RPCs. But if you implement optional RPCs, you should specify them using node get capabilities. For example, node stays volume is an optional RPC. And if your plugin implements this RPC, you should specify that using node get capabilities. And once you specify that node stays volume is implemented, by specifying that in node get capabilities, controller orchestrator is actually going to call that RPC, otherwise not. Uh, yeah, the other thing that I wanted to talk about is, right now, this communication, if you see here, it also specification also specifies that this communication between the container orchestrator and the plugin should be gRPC. Again, there are ways to expose your APIs. REST is one way. Open API is maybe another way, gRPC is another way. Why do we need all these things? Requires another video, let's say. But for now, we can just say that we can just say that uh, CSI specification says that your CSI plugin must implement all these RPCs via gRPC, and it must be exposed using Unix sockets. So if you see here right now, just Unix sockets are uh, Unix sockets are supported. But yeah, we are not sure. If you see here, network endpoint at which the plugin shall host CSI RPC services. This is the general format. And again, if you see here, all Unix endpoints shall end with .sock, and Unix is the only mechanism. Unix socket is the only mechanism that is supported as of now. The other thing that I wanted to talk about is, let's say you are running your CSI plugin. CSI endpoint is the environment variable using which you can specify where your gRPC server is running, or let's say where your server is running, that implements all these required RPCs. There are, again, now if you see here, it mentions all these details as well. I'm not going to get into all these details. But yeah, if you for example want to read through it, you can just go through the CSI specification once again. I hope that this video is going to be helpful to make you understand this specification. Very briefly, I would again like to talk about uh, the plugin modes. And if you see here we talked about node and controller plugin, but like I said, CSI specification doesn't specify how you can differentiate between node and controller plugin, or how your application is going to differentiate between uh, or how your binary is going to decide whether it has to run as a node plugin or a controller plugin. You can either use a flag to your binary, or you can use environment variable to your binary, anything that you like. uh, yeah, I think this would be pretty much it. In the next videos, we are going to obviously implement a CSI plugin, a demo or dummy CSI plugin, and we are going to actually implement or provision a volume on Kubernetes cluster using that newly written CSI plugin. So that would also be interesting. If you have any question about this, feel free to reach out to me using comments, or on Twitter. If you think this is going to be helpful to your colleagues, classmates, share it with them. Thank you so much for watching, and I will see you in the next one.